in the field such as medical and aerospace. As you may know, as the first session this morning, we will start with four engaging 15 to 30 minutes presentation with our Q&A from our speakers. Since we are not having the time for the Q&A right after the presentations, so please note down your questions. We will get this question addressed in the dynamic panel discussion. Here we will bring on a shared topic together and open the floor for an in-depth exploration through your questions. And in this panel discussion, we will have a video demonstration showcasing the entire product manufacturing process end to end. And to open the session of this afternoon, Professor Dr. Trần Trung Dũng will bring us a deep dive into the medical application of metal 3D printing. Please welcome Professor Dr. Trần Trung Dũng on stage.
The waves cut through me, hypnotized by the sounds I'm breathing in. Hold tight, chemicals collide. Hold tight, hold tight, hold tight. Dripping lights paint the skies, all because of you. Dripping lights paint the skies, only you.
Good afternoon, everyone, and thank you very much, Mr. Huân and Vinotech, and all of you. Give me a chance to be here to introduce some application of 3D printing technology in medicine. Let me introduce myself. I'm not an engineer. I'm an orthopedic surgeon. It means that I do more my work. My main work is with my patient. But when I work with my patient, with my surgery, I figure out so many challenges that I cannot solve without technology. So that's the reason why I focus more on using some new technology, 3D technology in our daily work, our daily surgery. First of all, I want to introduce a trend now, the main trend in medicine. That's the reason why the technology involved more in medicine, because the main trend in medicine now is the precision medicine. You may heard about precision medicine maybe everywhere when you come to any healthcare unit. Because the medical intervention is not one size fits all, and now is the era that we have to tailor-make the procedure, the surgery, or any intervention for each patient. It means that we come to the individual level. In the past, it's a community level. It means that we can have the same surgery for many patients, but now each patient, they will have their own surgical plan. And medicine now we have the P4 concept. P4, what does it mean? P4 is more detail about the precision medicine. P4, the first is a predictive medicine. The second is the preventive. The third is personalization. And the fourth is very important. That's the participatory patient into the diagnosis and treatment for them. It means that the patient have to take part in the way doctor and healthcare worker do the diagnosis and treatment for them, and they have their opinion. They can discuss to choose the best option for their treatment. And due to the precision and personalization in medicine, especially in surgery, you can see that on the screen is so many applications of 3D technology, printing technology in medicine. For the orthopedic surgery, my main, and for the other subspecialty, for example, cardiovascular, and so many things. That's so far we can see the application of 3D printing technology. In surgery, especially in orthopedic surgeon, orthopedic surgery, or maybe the dental or the facial muscular surgery, maybe so far the 3D technology we can separate into the two lines. The first is the resin 3D printing, and the second is the metal 3D printing. For example, for the resin is we produce a PSI. It means that's a patient-specific instrument to support for the surgery, or maybe the 3D model to support for the planning the surgery before the doctor do the surgery for the patient. For metal 3D printing, maybe we can see in the orthopedic, in cardiology, with the implant, titanium implant. But because of the precision and especially the personalization or individualization, it means that's the production 3D printing technology using in production for implant is very specific. It means that's so you can see that as a question in this morning, that is quite difficult to apply to widespread the using 3D technology in medicine. And so far, so many doctor and surgeon, they think that the 3D technology in medicine maybe high class technique or very expensive, and maybe they don't care. They don't care about the 3D technology because they think that they can't apply in their daily activity. So how to apply the 3D printing technology? I want to say our own experience. It's very important that we have to team up to be a group, a multidisciplinary teamwork. It means that the surgeon or the doctor have to work with the engineering, and we have to use the other software and other hardware to support. And this is the step by step in our 3D lab. The first thing we have to analyze and design. The doctor and the engineer work together, and then the doctor gives the surgical planning, and the engineering support the doctor to do the simulate and experiment surgery, and then we produce the PSI patient-specific instrument to support the surgery. And here is my team. And let me introduce our team, our 3D lab. We just maybe more than 2 years old, a little bit, established in 2022 in the collaboration between the BINMEC healthcare system and the university. And the main mission is education, research, and production in medicine. And here's we have some board of director and the designer team with the 4 engineer and the research assistant team and the clinical team with around 20 surgeons, 20 orthopedic surgeons, and now we widespread our network to other hospitals and other specialties. And to have a 3D lab effectively, we based on the 4 main pillars. The first one, you have a team, a clinical team. It means that this team will give the question to the lab, give the challenge to the lab, give the challenge to the whole 3D team. And the doctor and the engineer work together to find the solution to solve the challenge. The second one is the technical team. We have some engineers, they were trained in some other well-known lab around the world. And the first is operation team. And the fourth is very important, is just the equipment. We are very lucky to get the investment from Big Group to have quite enough 3D printing machine to support us to implement the 3D technology in medicine. Here's some of the machine in my lab, and I think that's I'm the customer owner view here. And for the operation, we have to get some standardization from ISO to produce. It's in ISO 13485 2016 or ISO 9001 2015. Before move to the main topic of my conference today is metal printing. I want to introduce some is the resin printing. It's more common in orthopedic surgery now or in medicine now. The most common product is the PSI, patient-specific instrument. We can understand that is the surgical guiding instrument. For example, it's for the very challenging surgery such as a total knee or total hip replacement. It requires the more precise. If we have the more precise, we will have the better results. So it's a conventional method. You think that's it? We have to use so many instruments like this to calculate, to realignment, or to measure the cutting or everything. But it will depend on the surgeon very much, on the surgeon experience very much, and a lot of instruments. And in the past, they have some other method to improve the quality of surgery by using robot or navigation system, but it's quite expensive to invest for to be the popular. And there are another way to apply 3D technology in surgery to get a better outcome. Is that this is a step by step we use to produce a PSI. The first one, we collect the image from the MRI, from the CT scan, and we reconstruct to make the 3D image. And the surgeon, the doctor will plan the surgery. And after the planned surgery, the doctor and the engineer will simulate to check again on the software, and then the next step is on the 3D model. It means that we print out the model and perform the experimental surgery in the 3D model. And after that, if we're happy with the outcome of that two steps, we will create the PSI, the color, the black or the green color PSI. It means that's the instrument to help the doctor to make the bone cutting precisely intraoperatively. This video is illustrates the cutting guide using the PSI. And in some cases, some difficult cases, we use the CT cone beam intraoperatively to check for the bone cutting to compare between the cutting between the plane cutting with compare the planning cutting with the actually cutting by the 3D by CT cone beam intraoperatively. And with the patient-specific instrument, we can say that we make the best become better, because we own the patient with our surgery using the PSI. They are very satisfactory. That's the time for the first one is the personalization. It means that we personalize, we individualize the surgical plan for each patient. And the second one is that we use the PSI based on the collaboration of doctor and engineering. And because with PSI, the accuracy of the surgery up to more than 99%. And because we template very detailed, so we minimize the damage. 100% of case of our surgery case, we don't have any complication. For example, the fracture or the injury to the nerve or vessel, or 95% the patient don't need the blood transfusion. Here's some figure of total knee replacement. We perform so far. We perform 100% total knee replacement with PSI. It means that 100% we use the 3D technology in surgery with the accuracy rate is 100%, 100%, and maybe more than a little bit more than 100 years we perform 117 cases for total knee replacement. And for the hip replacement, we do a little bit later. So far, we have 42 total hip replacement performed in with the accuracy rate is 100% as we plan. And with the total knee replacement and total hip replacement, so far we instruct to the doctor in the two other hospital. In Province Hospital, they can use that to do the surgery for them in Hà Tĩnh Province Hospital and in the Bắc Giang Province Hospital. And the PSI we can use it not only in total hip and total knee replacement, we can use it in some other surgery such as for bone cancer. For bone cancer, we measure the precise cutting, bone cutting, and we produce the PSI. Support the surgeon to do the precise cutting intraoperatively. And the other application, you can see this is a very complicated deformity of the tibia bone with the two levels. In the proximal tibia and the distal, we use the PSI to perform the corrective cutting bone. Then we realign and we put the plate and screw in. And this patient, they have finished the surgery 1 year ago, and now with good result. And last week he come to me to prepare for the left side surgery. And the other case with the deformity of femur, you can see the deformity of femur, and then we use the PSI here to make the bone cutting to realign the femur and put in the implant. So after the surgery, the patient, the length of the femur is 5 centimeters more than in compared to the pre-operation. You can see on the left side is right after we perform for the right side. So you can see the shoe on the left side, that's 5 centimeters higher. And then he's that patient after the 1 year for surgery on both sides. So you can do some gym and so you can sit like this. Another application is using PSI to guiding for the surgery for the small cyst of thallus. It's a very difficult surgical technique that you can do by yourself. You can do by freehand. You cannot do that. And with PSI, we can do the surgery very precisely. And this solution, we get the award from the national contest in 2022. And the other application of 3D printing technology is just a model, anatomic model. This is a big tumor in the abdominal, and we have to do the surgical planning based on the 3D model. With collaboration between so many surgeons, from orthopedic surgeon and neurovascular surgeon and GI surgeon, to work together to remove the tumor based on the anatomic model. Now this one, you can see this facet joint cyst of the spine. To support for the minimal invasive surgery, we create the 3D model to find a way to make the bone cut and to take the cyst is only 1 centimeter diameter. And the other case of the deformity of the lower limb with using PSI to realign for the lower limb. That's the picture is right after the surgery. And the other very difficult case is with the dysplasia of ulnar. You know, this is dysplasia of ulnar, and due to the dysplasia of ulnar, so the radial bone dislocate from elbow joint. So how we can correct it? It means that we have to realign the ulnar, and we have to lengthen the ulnar because it is shortened 2 centimeters in compared to the radial bone. And you know that the ulnar is the deformity in 3D direction. So we have to use 3D technology to prepare for the surgical plan. And as you can see that we make a small incision to make the bone cut here, and put it 6 pin in the ulnar joint, and after that we realign 6 pin and put in the external fixator and lengthening every day. So after the surgery, you can see the 2 hands. Left hand is a hand after we realign the bone. And another using a PSI to corrective osteotomy for the tibial cubitus valgus. And this is for the bone cancer. And this is another for the osteotomy. And there's some other using 3D printing is also we creating the molding for the reshape for the titanium mesh to cover for the brain. And in other specialties such as cardiovascular, the 3D model in support for the cardiovascular doctor to planning for the intervention to put in the stent graft. And this is for nephrectomy with planning by the surgical model. And now coming to the metal printing. If the resin 3D printing can help us to do the surgery more precisely, so the metal printing can help us to have the solution for a very challenging case. But it's very difficult to use metal implant to metal prothèse to implant into the body, into the patient. To do so, we have to, as the requirement from Ministry of Health, we have to implement 3 research. The first one is that we have to test the mechanical property. The second one is that we have to test for the toxicity. And the third one, we have to do a clinical trial in volunteer patients. Even that the machine and the material in our lab we imported and then have the FDA approved. But as a requirement of Ministry of Health, we have to perform the research again. And we passed the mechanism property test, and we also passed the toxicity test with so many. This is the certificate for the mechanism property test, and this is the test for the toxicity with so many criteria due to the follow the instruction from Ministry of Health. And we passed 2 tests. After we passed 2 tests, and now we come into the third research, is that we perform the surgery on volunteer patient, a small sample up to 10 patients. And this is a very difficult cases. that we performed 7 months ago. The patient has a bone cancer in a very difficult location in the hip joint. You see here, and this is the video before he do the surgery. He couldn't walk. We have to use the crutches because we cannot have weight bearing on the right side. In the past, if we don't have 3D technology, 3D printing technology, we didn't have the solution. The solution for this case in the past is that the first one is that we do nothing. The second one, if we perform the surgery, we have to perform the hip articulation, and bigger than hip articulation, we have to perform the hemipenvectomy. We have to take out the penvectomy. It's a very big surgery with so many complications, and the safer choice for the case like in the past is that we do nothing. We advise the patient come back home and take some palliative treatment for painkiller or anything. And with the 3D printing technology, we can perform the surgery to tumor resection, and we can replace it with the prosthesis we produce in our lab. This is a video illustrates how we can perform. We have to create the PSI to help the surgeon to cut the bone tumor, and we produce the implant, replace it. This a structure with lattice structure. That's PSI to support for the bone cutting. And we replace for the proximal part of the femur. Okay, the surgery is very successful with no complication, no any injury to nerve or vascular. And this is the video after 6 months. So far it's 7 months. This is at the time 6 months after surgery. The patient can walk well with no crutches, no pain, free of pain. And there's a difficult case. That's a bone tumor of the proximal humerus in a very young children, 13 children. For the case similar like this, but in adult, we have the mass production prosthesis to replace. It means that we can do the surgery quite easily. But for this patient, the bone and the joint is very small, so we don't have any mass production implant. We have to produce from our lab, and this is the design. And this is the intraoperatively we replace, and you see that we design the tendon insertion here to repair the tendon insertion. And there's some other case with a very small. This is the navicular bone, and this is the talus bone. All they suffer from the bone cancer. And here is another case for scaphoid bone of a long run driver. And this is after 6 months, he can do everything well. He can come back with his work. And this is some other application here, because I don't have much time. So move to the back as the last. In our perspective, we think that 3D printing technology will come involved more in the medical field, and maybe we think that there's something new in the future. The first one, that's one project we are following. That's we create a digital twin patient. It means that we model the muscle, the bone, and to make a model of each patient. And we can predict. We can predict about the injury. We can predict about the degeneration. We can predict about the trend after, before, and after the surgery. The second one is we use AI in the design and in the produce prosthesis. We have a collaboration with a group from Israel to use AI to save time in the designing. Maybe from the 2 hours for the sample design to 15 minutes. And the third one, maybe you know, that's the application of AR, VR in the surgery, in the create the model. And it's very important for thinking about the mass personalization or customization. The high cost of the 3D printing technology due to that we only produce one by one. But in the near future, I think that we can move to the mass personalization. It means that we can, one time we can produce 10 or 20 model. So with that we can reduce the cost. And the last but not least is that bioprinting. It's a new trend that we have a small group working together to think about the bioprinting to produce some, for example, the ligament or the catalyst or something else. That's a new trend. Okay, thank you very much for your help because I don't have much time. Okay.
Stop in time. Yeah, I'm surrendering. Hold tight. Chemicals.
Thank you very much, Professor Dr. Trần Trung Dũng. And now, to deep dive more into the AM in the application for the medical field, I would like to invite Mr. Hoàng Đức Bằng from AIE to talk about AM in medicine, the medical business cases.
Paint the skies. Only you can make me move. You can make me move. Can make me move. Can make me move. You can make me move. Can make me.
Good afternoon, everybody. First of all, I would like to thanks to Vinotech and everybody here give me a chance to share AM in medicine and some business case. My name is Bang. I'm from the CEO of AIE, and we are the pioneer company in Vietnam, supply the technology. And I am a passionate of the 3D technology, especially in 3D technology, 3D printer. I started selling the first printer in Vietnam in 2003, and our company started in 2005. That is, today I would like to share some information about the 3D technology in medicine. So we already saw the presentation of Dr. Dung, and we can see that many successful cases and application of 3D printer for medicine in Vietnam, especially in Center 3D Technology in Vinmec. And now I would like to share some information in the world. And I would like to share what technology is proper for method 3D in medicine. So my presentation has 4 parts. The first one, why AM in medical, and the second one is what technology should be good for medical application. Because we know that there are many technology in metal printing nowadays, laser or electro beam, and we share the medical business cases. And finally, we would like to introduce you who is Colibrum additive. So why AM in medical? I don't need to say more because Dr. Dung already said. Yeah, you know that we can bring the many application, many part, many to implant to the body. So I no need to say. So what is the benefit for orthopedic industry? So the first one is you know that there is a freedom to design. You already see that for the personalized, so you can easy to design the implant part. The second is complexity is not an obstacle. For me, now easy. You can do everything, like Dr. Dung already saw, showing that very easy to replace a part if customer want to do that, and you can do. Mechanic of the body also now is easy, and so with porosity, with the porosity, with lattice structure, so the part can easy to done. Also very light in the body. We can have a one implant, and also it's a flexible and efficient production. So that is the benefit potential that for the medical you can use for METAMAN AM. So now I would like to share the outlook for industry in medical market. So this is that statistic showing that METAMAN AM now the penetration between 5 to 8% of 1 billion ortho implant in the manufacturing industry. AM now is in many aspects more effective compared with the conventional processes. So we can see also the doctors already show that. And for the data static, we can see that you can see the dark blue is powder bed fusion is the application, and the other is ED or BG is by the jet, so application. So in the number of million $, so you can see that powder bed solution fusion is the dominant technology AM. In the world, you can see that in the US, it's 61% is for the orthopedic industry is the application. Asia Pacific is 9%. Europe and America, so 25%. And Vietnam, now we are starting. And Center for 3D Technology of Dr. Dung, I think it's the first center, the first organization is the application of that. And we hope that Mr. Dung will help to increase number in Vietnam application. So medical device manufacturer currently own 20% of the METAMAN AM machine. And for the forecast is over next 5 years will be more than 3,000 AM machine can ship to the medical industry. So that's data is since 2018. So I think now it's more. So here you can see is a one. AM already established in the industry and in the world. And you can see that according to GE Additive, more than 900,000 medical devices was sold in over 20 years. And you can see that the FMI instrument is the first FDA registered and approved also is ISO, oh sorry, ISO 13485 by using laser technology or EBM. Material also, you know that here you can have Mr. Moon Chun Lim, yeah, also has showing that. And in China, AK Medical also get 3 CFD, FDA, China FDA for the application. And since 2015 and 2016 using EBM technology. We have also other like Exatec, Lima also is the first, also very last application. I think they have more than 100 machine from the GE additive. Now it's clear. Striker also. So that is, you see that's the application all over the world, very popular. Vietnam now is starting. So where you can use metal printing part for the body, so you already know, yeah. So you can see that shoulder, elbow, hip, maxillofacial, spine, knee, many. So where it's moving, so I think it's the place is for the printing part. So application for the joint implant, so you can see here also Dr. Zook already showed us how is the benefit, but I can only show you the conclusion that 99.3% at 5 years implant survival rate, that means the successful rate of the application of that hip is. So for craniomaxillofacial implant, we can customize, can short manufacturing and patient fit allow the short, efficient surgery. So the conclusion comes from the interview of the industry expert, up to 30% reduction time to the market and up to 30% cost saving. That means for the surgery. So I think that is a very good number. How about the spinal implant? Can provide customer, patient comfort, design freedom, additional feature and flexible production and reduce time to the market. Also, Dr. Zung already showed us some cases. And so we can allow up to 75 of the implant to be filled with the graft material to maximize bond operation. So that is a quote from 4WEB Medical. Also, one is application for the medical is instrument, surgical instrument. So you can use to bring the surgical instrument for flexible, for the innovative design and cost efficient, like to also to make the PCI, PSI. So up to 60% reduction time to the market. That is, we can see that's a very many benefit for the application is medical of the 3 metal. So we know that there are many technology nowadays for metal 3 printer. So what technology is good? DMLM, that means direct metal laser melting, or short is laser technology. And the second is EBM, is electro beam melting. So what is the good and what? So we can see the comparison. So for the printing process, we see that the quality of the part, mechanical properties, cost of the part, and time is affected by many variables. So you can see that the part design, geometry pre-design, lattice structure, etc. So we have to ask Mr. Lim for the material support for that. Feedstock, which material, powder condition, process parameter of the printing, bin job, layout, post processing. So many variables can affect the quality of the. So we have to consider that. So after some research and comparison between the laser and EBM technology, you can see that for the laser technology, you can get some 5 detailed part, 5 surface finish. Each power removal easy, and broad material you can measure many selection of the material. For EBM, you can get no residual stress, high productivity for large volume, use little, no support, or low powder coat. So for EBM, you know that the material is melting, metal is melting in the vacuum condition, also with a high temperature, constant temperature. So there is no threat in the metal inside the part, and after that, we no need heat treatment, and the quality of the part is very good. So how is the EBM process? I can show you a video. Cannot run? Okay.
Additive manufacturing offers greater freedom in design and allows for the creation of optimized parts that are not constrained by the limits of traditional manufacturing. RCAM EBM has the unique ability to tightly stack parts within the build in order to increase productivity. An optimized build file is sliced and loaded into the RCAM EBM system. Following this, metal powder is loaded into the machine. The build chamber is then closed and a vacuum is created to ensure a clean, controlled environment that allows for the processing of reactive material. Next, RCAM EBM's powder layering system evenly distributes a thin layer of powder on the build area. A powerful 6 kilowatt electron beam heats the powder bed to the optimal ambient temperature and then proceeds to melt the powder. First, contour melting and then hatch melting. The electron beam unit generating the beam contains no moving parts, allowing for extremely fast and accurate beam control. The build environment is kept hot, reaching temperatures exceeding 1,000 degrees Celsius, resulting in no residual stresses and allowing for the processing of crack-prone materials. As each layer is completed, the build is lowered and a fresh layer of build powder is raked over it. This process repeats, growing the build one layer at a time. When the build is complete, the tank is extracted and the RCAM EBM machine is prepared for the next build.
So that is what is EBM working. And you know that for the laser, the temperature of the part, the print part is fluctuation. Because after laser melting,
additive manufacturing offers greater freedom in design
powder
and allows
temperature
for the
decrease
creation of optimized parts
against
that are not
laser
constrained by
melting,
the
so
limits of
temperature is
traditional manufacturing.
and there is a stress
RCAM EBM
inside
has the unique
the part.
ability to tightly stack parts within the build in order to increase productivity. An optimized build file is sliced and loaded into the RCAM.
Okay. So that is some, I think, why is the phone is different, yeah? So it's changing. Okay, this some research to comparison of the laser technology and EBM technology with the strength, in strength, tensile strength, and elongation. So you can see that for EBM is extend elongation is better. The tensile is softer and less brittle. So that is very good for. Code calculation per part. This is an example of the hip cup. think it's a furnace. No, no. Not that. Not yet. Okay, so that is. So we can see that the cost per part in euro, with the cost of the part is combined of the many factor like a material, bed setup, position, the recoating, many. Sorry, that's because the phone is changed, so you cannot see clearly. So many factor of the process. So for the hip cup, its size is 54, 54, and 45, with volume is 25.1 cubic meter. So we can use support is for 3.4. It's with EBM, and for the laser is 6.5 cubic meter for the support material. So we can see that so the Q10 plus of the ACAM is a very good machine for the. It's a production time. Also, we can see that the EBM is a technology also with shorter. So that is what technology I think you can see that's the advantage of the EBM technology for the medical. So now we can share the business case is one. So Lima is the customer of the so now they produce 145,000 units of in 10 years with EBM. They have a 9 EBM product machine is from since 2007, 2018. So we can see that the growth of the Lima of the application for the EBM in medical. For WEB medical also you can see that's more than 40,000 implant in 5 years. This company is founded in 2008, and you can see that's the first company received the FDA approval for AM spine implant in 2012. That's very earlier. His is in the AK Medical is China. So China now China market also very large and very booming for it. So we can see that they are using also the EBM technology. Increase revenue more than 100% in 2018. That is, I think there are more application and many case study you can find in the website of Equilibrium Additive. So that technology, what I introduced, is now is belong to Equilibrium Additive. That is a GE Aerospace company. So who is that company? Actually, it's Equilibrium Additive is a GE Aerospace company. Before that, it belong to the GE group, and GE in 2014, the LEAP engine, the first LEAP engine of the GE, the engine of the aircraft. So she applied this technology for the aerospace, and step by step, GE see that the potential application for aerospace, and they set up the G Additive company in 2006, and after that they acquired Concept Laser from Germany and Akkam from Sweden, and 2017, so they bought also is APC and Gion, step by step, and in 2024 they set up the Colibrum Additive. The name is aerospace company, so it's more the focus for the additive application. So with the Colibrum, we can provide the customer the ecosystem. So we can provide machine modality. We can provide concept laser with laser technology, E-beam technology. We can provide the material powder. It's from the APC. APC is a very special company in Canada. Provides material, titanium, very special for medical application. We can have an at-work consultancy for the support to customer with software and customer experience, and we also have a partner companies, so we can see that have a ecosystem. For the machine, the modern is application is good for medical. The first one is MLab, is a laser technology. MLab 200R. So is this machine? We can use different material, and for the medical, for the dental. This machine is an advantage that you can change the material powder. For that, some laser technology or some big company, big machine, so very difficult when you change the material. So we have normally we have one machine for one material. If we have another, so we have another machine. So, but with MLab, we can easy change material. So it's for the research, for the small lot production. So very easy, flexible production and rapid change of material.
Sorry to interrupt, but Mr. Bang,
Okay.
due to the time schedule.
Okay. And we have a M2. It's a laser technology also. It's similar with the SIM 280. And we have also the Q10. It's a EBM. It's also a very convenient for the medical application. So it's a cost estimation and comparison of the when is good for the application. So I see that compare MLab, Q10, and M2. So we can see that is for the small batch, 2,000 part. We can see the advantage. The cost is MLab, but if the higher, so we can see the Q10, and more expensive is the laser. But if the part is more like because Dr. Zhu said that for the mass production, how we can consider it's a low cost. So this is, you can see that the EBM Q10 is the best. Okay, for powder, you can have from the ABC from the Canada. I already said. So what is the at work? It's like a inset and tune with 20 years experience. So GE can support and consulting the customer to help the customer develop a part, make the prototype, speed up process, validation process, and moving to production. So you can help customer to validation the process, the instrument quality, operation quality, product quality. So you can set up together with customer to get the certification. So that is a proposal project workflow. So first we have a validation workshop, readiness assessment, we make a plan, executive, phase 1, phase 2, summary, and we can get the report. Okay, you can get certification to have the customer to get certification. And we know that we can see Dr. Zung showing just a list of certifications, the process we have this, so we can together with customer to set up validation and to get certification. With 20 years of EBM, so we can together with customer develop the process. So, summarize, why equilibrium additive? We are having the right technology. Powder traceability and quality is key. With ISO and certificates, certified, we have a deep expertise to have the customer assess. Customer can assess to G family, healthcare, Capitan, research. G also is a power user of the METAMAN technology. And finally, we want to be successful with the customer. And slogan of the GE additive is smooth your path to METAMAN additive production. So we can together to make the smooth path to production. So thank you very much for your attention.
Thank you so much, Mr. Hoàng Đức Bằng, for a very interesting presentation. I guess you all get a wonderful knowledge in the field of medical. And next, we're going to know more in the ASTM additive manufacturing technology standards from the presentation of Andy Liu, introduction on key metal AM standards and methods of qualification and certification for metal AM production. Please welcome Mr. Andy Liu.
Hello, can you hear me? Hello? Oh,
I can hear you.
Can you hear me?
I can hear you online.
Okay, just a moment.
I'm not sure the crowd.
Oh, you can hear me, but I think they cannot hear. Maybe let them know. The online participants can hear me, but can the okay. Thank you. Shall I start? Yeah. Okay. A very good afternoon to our friends and attendees from Vietnam. This is Andy Lu from ASTM. Unfortunately, I cannot travel this week, but I'm really honored to be invited by the organizer Vino Tech to give this short presentations on introduction of key metal AM standards and also methods of qualification and certifications for metal AM productions. Without further ado, let me start my sharing. First of all, please allow me introduce who we are as ASTM International. So ASTM International is an organization established in 1898, 126 years ago. Up to date, we have more than 150 committees and published more than 13,000 standards globally. So in the world, we have 34,000 members and signing more than 110 MOUs globally with different countries. So this is a quick overview of who we are. And on the right, you can see the roadmap about our presence globally. So let's go into the strict focus. So among all the 100 plus committees, we have this F42 committees focused on developing international standards dedicated for AM, additive manufacturing. So we established this committee since 2009 which is currently one of the oldest and the largest committee on AM in the world. So up to date, for this committee itself, we have more than 1,300 members globally, and we already published more than 72 standards, and another 62 standards are under development. So in 2011, ASTM signed a joint agreement with ISO, which under their committee is called TC261, which means from 2011 onwards, all the global AM standard will be ISO and ASTM joint standard, which I'm going to show a few key examples at my later slides. So you may asking how we develop our international standard. So actually for ASTM, every year we host 2 global meetings, one within US and one outside US. So as you can see in Asia, we also had meetings in Tokyo, Singapore, Korea, and actually next year we are going to Philippines. So during the meeting, people will actually vote and confirm the final published standards across the global attendees and the participants. Okay, without further ado, let me briefly introduce some of the key standards. And before I move on to details, I want to quickly share there are actually different types of standard coming from the complete standard, such as what AIE shared earlier. For a company like GE, they may have their own standard. And after that, there may be consortia standard, which means a few companies or a few parties join together, forming their standard. And moving the next, you will have industry standard, such as aerospace, medical industry, or automobile industries may have their industry standard. And after that, you will have government standard. For example, US has the US internal standard. For Vietnam market, there will also be specific country-driven standard. And then lastly, we will have our global voluntary consensus standard, such as all the ASTM and ISO standard. So in the next few slides, I'm going to show you a few examples of the key standard relevant to AM progress and development. And I will and where all the ASTM ISO standard sit here. So first of all, I would like to give you a quick overview of, I will say, the top 5 standard if you are actually printing metal AM. And up to date, I think there are actually more than 20 to 30 standards already published. So I picked probably top 5 standard for everybody's reference, and you can actually learn and learn from the standard. So first, we have this ISO ASTM 52901. So as you can tell from the title, it's actually a standard guide for AM, general principles. It will actually guide you what's the requirement in order for you as an end user or suppliers to prepare a purchased AM parts. So moving to the next, we have ISO ASTM 52904 standard. So this is one of the best practice for metal powder bed fusion process, which is also known as SRM or DMLS or various metal laser technology, to meet critical applications, especially aerospace and the medical. So this is second. And moving on to the next, if you are looking at more machine relevant for metal AM, we have this ISO ASTM 52941 standard. This is actually a standard refers to system performance and the reliability acceptance test for laser metal PBF machines for metallic materials for aerospace. So this will be a very critical method for aerospace users if you want to qualify or even certify your machines. And of course, if you are printing metal parts for other industries, this standard can also be a very good and helpful reference. And moving to the next, we have operators. So we have a standard like ISO ASTM 52942. So this standard actually is here in order to qualify machine operators of laser metal PBF machines and equipment used in aerospace applications. So similarly, if you are printing aerospace parts, this will be a critical method or standard for you to qualify your operators. Otherwise, if you are printing metal parts for other industries, this standard can also be a good reference and a guidebook. And lastly, which is also most important for nearly all the critical applications, we have our standard ISO ASTM 52930, which is actually a guidance document on installation, operation, and performance qualifications for AM productions. So this standard actually dig into details of all the requirements of like IQ, OQ, and PQ. So this 5 standard, as a nutshell, they are actually a cooperative effort driven by various end users globally. And that's why ASTM, serving as a platform, gather everybody together to develop the standard and with the aim of supporting and helping more end users in the AM industries. So the next, just want to also share with you, besides existing standard, we do have various standard under WK. So WK means working in progress. So as you can see, we have different topics such as metal feedstock, metal testing, and also the NDT or in-process monitoring. So all these different category standards are working in progress. And with these standards published very soon in 1 to 2 years time, it will better help and guide every end users to better perform, investigate, and test your metal printed parts. Okay, so with this, I briefly shared from ASTM International, 126 years old organizations, what we are doing in publishing all the standard, guiding the end users under the F42 committees. So additionally, I would like to share, besides ASTM International, or under ASTM, we have our department as AMCOE, AM Center of Excellence. So for this department, we established for 6 years, and we actually focus on 5 key topics, including supporting R&D in AM, focus on training, developing the workforce for the industry, giving standards and the certifications programs to end users, having consortiums for metal or especially powder materials. And lastly, we acquire Wallace Associate, providing advisory and marketing intelligence. So moving to my next part, I actually will jump into our Wallace Associate, providing some high-level market insights for the AM industries. So a big background, in November 2021, Wallace Associate acquired by ASTM, and that's why we start to offer advisory and the reports and market intelligence. So in the latest year, we have our Wallace Report 2024 with tons of data and informations to be provided to our end users. So in the next few slides, I'm briefly sharing some of the key content and highlights of the AM progress. So first of all, we would like to share some of the information on M&A, mergers and acquisitions. So in the year of 2023, we actually noticed 33 transactions in M&A in AM industries. So compared with 2 years ago, 21 transactions, there are actually a 57 increase. So it actually shows AM market start to consolidate and also prepare to take off for the next stage. So more importantly, we are actually also looking at our global revenue for the AM industries. So based on Wallace data in 2023, there are actually 20 billion US dollars AM market, and including a portion of products, sales, and also service provided. So in the past 5 years, the annual growth rate is around 14%, where over the past 35 years, we are expecting annual growth of 25%. However, we do want to highlight in 2023, the global manufacturing market is actually US dollar 15 trillion. So the AM market is still relatively small compared with the whole manufacturing market. It only counts for 0.13%. That's why everybody is still expecting a high growth for AM, and hopefully in another 5 to 10 years time, AM market can reach 1% of the global manufacturing market. So looking at various industries, we do have the technology readiness levels and acceptance. So as you can see here, in various industries, spaceflight, medical, and aviations, they're at the highest maturity, where these few industries are already adopt or even move on to the mass production skills for AM. The next wave coming from like maritime, oil and gas, automobile industries. So they are ranging in the index of around 4 to 7, which means they are probably already entered the small series productions, but they are actually will be taking off very soon in another few years' time. So besides all these key industries, new industries like constructions and electronics are also growing in the recent years. So this is a quick overview of different industries' growth and progress. Okay, so moving on. How we have all this standard can enable various AM supply chain and how we can leverage on the standards. So as we should, globally, right, we have different types of standard from company, from country, from industry, or from like international standard. So here we listed some examples such as NetCap, ISO ASTM, AMS, AWS, API, NASA, or like FDA requirement, or LR, or DMV. So the questions for every end users will be, how do standard enable their AM supply chain? So in order to fulfill different standard or requirements, the approach will be similar. So in short, you need to prepare the following systems, such as existing QMS, how you control your digital information workflows, how you receive, handle, and store your materials, how you control your facilities, how you do the post-process, how you do the requirements for H&S, and what's your corrective and preventive actions. So as an overview, we have different levels in order to qualify or certify your product. You start with your foundation, moving on to peoples, and prepare your facilities, get ready for your material and data, get ready your whole Q&C systems in place, and eventually you can achieve high quality product in mass productions. So using Metal AM as an example, so here we actually show a detailed mapping from the start to the end, how you utilize various standards to qualify the whole systems, starting from materials, mechanical properties, design for AM, classification of part, preparation build-up, safety, the whole hardware preparations, and the whole post-process. So actually this map, we actually do have 2-day full training to go through details, which I'm going to cover at my last part of my sections. So as a summary, how we leverage on standard. So here just to show a few more relevant standards in order to qualify or certify the process. But I won't go into details for today. So just to alert for all the certification or standard I mentioned just now, ASTM is just a platform and organizations. So eventually it's actually the end users are driving the effort to standardize and unify the process. For example, just this week, ASTM announced our latest AMCC, Additive Manufacturing Certification Committee, composes of the founding members of 23 companies. So as you can see, we have key aerospace customers such as Boeing, Honeywell, Lockheed Martins are inside. We also have key medical end users such as J&J, JI Optics, Medtronic, and the Strikers sitting in this committee to standardize our global certification effort for various AM users. So to unify the requirements for AM supply chain in various industries. So lastly, I would like to briefly share what we are doing in Asia as ASTM, organization headquartered in US. So we do have wide presence in the whole Asia across different regions such as China, Japan, Korea, Singapore, Vietnam, Philippines, India, and Middle East. So as I shared earlier, our 2-day full course in terms of the qualification and certification for AM become very popular. So even early this year, we already organized in Tokyo, Daejeon in South Korea, and Singapore. And then we do have upcoming rounds in like Osaka, Seoul, Singapore, and Tokyo again in the next coming 6 to 12 months. Additionally, we do also planning overseas study trips for Asia users to US or Europe, such as FDA in the US or GV Aviations in the US, or even visiting our ASTM headquarters to know the latest standard. So all this will be big values for our end users to know more about the industry and to learn from the best practice. Okay, so to summarize, from ASTM, AM, COE, our Global Advanced Manufacturing Departments, we have a team of 30 experts with 10 PhDs and 15 masters. We will try our best to support all the AM end users in the world and particularly in Asia. So we are here to support you, answer your questions, especially how you utilize the standard as a reference to do your business. So thank you very much, and also thank you for the organizer inviting us. And feel free to email me or WhatsApp me if you have any further questions. Yeah, once again, thank you very much.
Thank you, Mr. Andy Liu. It's a very interesting presentation. And next, to know more about the metal 3D printing can enhance the manufacturing process, Mr. Levan Fu will continue to introduce the smart additive manufacturing solutions. Once again, please welcome Mr. Levan Fu from Hexagons.
Good afternoon, everyone. Thank you for giving us a chance to on our smart additive manufacturing solution. My name is Fu. Especially thank you for Inotech. First, allow me to tell you about Hexagon. I would like to introduce about Hexagon. We are a global leader in digital reality solution that we empowering an autonomous sustainable future by putting data to work. We believe that to empowering a sustainable future, we need digital reality solution. Thus, we step out from automation to autonomy. So what we do, Hexagon is a global company. We do in many scopes, especially we have 6 major divisions. And I come from Hexagon Manufacturing Intelligence. So let's take a briefly look on Hexagon. Hexagon build a strong base from innovation. Come with innovation, we set the bar very high. Every year we invest about 12 to 10% of our revenue for R&D. And we have around 5,000 R&D employees. Completely, we focus on innovation. Okay. We have around, up to now, we have around 4,000 active patents. This result validate for our innovation process. So, our relevancy in the market is vital. Our customer find us and remain us because we are strategically and critical to their success. We Hexagon serve the vital service industry, from manufacturing to infrastructure, construction, city service, and more. So our stability is speak for itself. Up to 2023, we reached revenue 4.3 billion, with profitable increasing. And up to now, we have more than 22,000 employees across 50 countries. Sustainability is an integral part of our strategy. We commit to driving profitable business value that ensure economic growth, but not at the expense to the planet or people. So what we do with our distribution to develop up manufacturing on automobile, aerospace, and aircraft. We can say that global industrial run on hexagon. So look at the value. This data we calculate from July of 2021. Hexagon support about 95% of all car produced, 90% of aircraft produced, and 75% of smartphone produced, 80% for orthopedic implant produced. So let me say what we said today is related to our event. What has happened? We have design and engineering and production, metrology inspection. For design and engineering, we have on the software related to R&D and manufacturing simulation software. For production, we have the machining production software application. And for metrology and inspection, we have various types of inspection machine and data management software. So for design and engineering, we have structure analysis, multi-body dynamic, thermal and fluid dynamic, acoustic simulation, material modeling, manufacturing process simulation. And for production, we have production machining, mold and die, and manufacturing, sheet metal fabrication also, and wooden making, CNC simulation, and factory automation. For metrology, we have metrology analysis, and we integrated metrology equipment to machining center. And we have robot calibration and the reverse engineering. So for talk about additive manufacturing, actually it has many things, many steps inside. So let me show you. We integrated on the step from design, engineering, followed by quality inspection. Look at it. For additive manufacturing, Hexagon have almost application software included software and hardware for beginning to the end of step of additive manufacturing. Let me show you a video about hexagon solution of additive manufacturing. We have a platform to control this. This is our platform. We have when we input all the data to project from type of project, manpower, material, everything we put in this platform. So in this platform, you can input all the data of one project from material, manpower, and what software we use in this of the project. Okay, so I would like to show you one case study that hexagon apply ID. This is one case accident, and the hips on portion were broken. So firstly, patient will diagnose by CT scan to get decom image. After we have decom image, hexagon have one we have the software to convert decom image to the mesh. After that, based on this mesh, we do simulation for 3D printing. After that, we do the real 3D printing. After we have the actual part, hexagon have equipment to check again the quality of 3D printing by our scanner. And after inspection, the joint is ready for using. Okay, thank you, everyone. So if you have any, maybe in the morning, our colleague, my mother already talked to everyone, Mr. Vara and Mr. Cameron. So if you have any question, you can contact with us. Thank you.
Thank you so much, Mr. Levan Fu. It's absolutely very interesting. And this presentation also clears the first part of this afternoon. We'll have a short tea break before the second part. And we have already prepared a tea break for all of you. Please feel free to join and help yourself. The second part will happen within the next 30 minutes after the tea break. We'll see you then. Thank you. Dạ, chương trình có tổ chức chương trình có chuẩn bị phần tea break cho mình ở phía bên tay trái của sân khấu ạ. Mọi người có thể qua để sử dụng tea break. Và ở cuối khán phòng thì mình có 4 cái booth thì mọi người có thể tham quan qua các cái bộ phận của in 3D ở dưới đấy ạ.
khoa, công nghệ in 3D kim loại đang mang đến một cuộc cách mạng trong việc tạo ra các cơ quan trong cơ thể con người. Và kỳ vọng trong vài năm tới, Việt Nam sẽ trở thành một trong những quốc gia có thể thay thế các bộ phận bị tổn thương của con người bằng công nghệ này.
Ghi nhận từ hội thảo công nghệ in 3D kim loại, những đột phá trong phát triển sản phẩm và sản xuất một số ngành công nghiệp vừa diễn ra tại thành phố Hồ Chí Minh. Tại hội thảo, các chuyên gia đã chia sẻ giải pháp ứng dụng in 3D kim loại vào lĩnh vực y học khi chế tạo được những phần xương nhân tạo từ vật liệu titan. Những phần xương này có tạo hình hoàn toàn khớp với cấu trúc của đoạn xương bị thiếu, được cấy ghép vô cùng chặt chẽ vào cơ thể người. Sản phẩm này được tạo ra qua quá trình bồi đắp vật liệu theo từng lớp chồng lên nhau, một xu hướng mới trong ngành in 3D hiện nay. Công nghệ này đã được chứng minh độ an toàn trong lâm sàng và đã được áp dụng tại các nước như Mỹ, Trung Quốc.
Cái công nghệ bồi đắp này đó là nó sẽ đắp dần từng điểm vật liệu, nhựa hay là kim loại, sẽ thiêu kết từng cái phần tử vật liệu ở dạng một kết nối với nhau để tạo thành cái sản phẩm. Và hiện nay nó có những cái ứng dụng đặc biệt liên quan đến y học tái tạo. Có thể nói là đây là một cái triển vọng cho cái lĩnh vực y học tái tạo ở trong nước.
Lĩnh vực mà in 3D áp dụng vào ngành y tế là một trong những cái mảng mà được ứng dụng nhiều nhất ở trên thế giới. Và cái in 3D cho cái ghép y tế là nó rất là tối ưu, không chỉ là về mặt độ chính xác, kích thước cho từng người, cá nhân hóa cho từng người, nhưng mà nó còn giúp là kết nối với xương tốt hơn và nó tạo ra cái hiệu quả tốt hơn nhiều trong cái việc mà cấy ghép trong y tế.
Vinotech hiện là một trong những doanh nghiệp đầu tiên đầu tư công nghệ in 3D kim loại vào lĩnh vực y tế tại Việt Nam. Công nghệ này sẽ giúp chế tạo các thiết bị hỗ trợ quá trình phẫu thuật nhanh và chính xác, chế tạo các bộ phận cấy ghép trong cơ thể người.
Gần đây chúng tôi đã lắp đặt một cái hệ thống máy của hãng SM Solution cho một cái khách hàng rất là lớn ở Việt Nam, chuyên làm trong cái mảng cấy ghép y tế. Và trong vòng 1-2 năm tới đây thì chúng ta sẽ thấy là những cái sản phẩm in 3D kim loại cấy ghép trong y tế sẽ được làm ra tại Việt Nam, và tôi tin rằng đây là cái lĩnh vực mà Việt Nam sẽ phát triển rất là mạnh trong thời gian tới.
Để mà có thể áp dụng các cái sản phẩm này cho bệnh nhân thì phải trải qua một cái quá trình thử nghiệm lâm sàng và qua cái sự chứng thực của cái hội đồng y Đức để người ta khẳng định rằng cái việc thay thế này là an toàn cho bệnh nhân. Và trên thế giới đó, nhiều nhất ở Mỹ hiện nay người ta sử dụng trong cái thay thế khớp gối.
Những năm qua, ứng dụng in 3D đã tạo nên nhiều phép màu khó tin cho lĩnh vực y khoa, chăm sóc sức khỏe con người. Không bao lâu nữa, các bác sĩ tại Việt Nam đã có thể tự tin sử dụng công nghệ này để tái tạo một số bộ phận cơ thể người, mang đến cuộc sống chất lượng hơn cho người dân.
It's kind of a unique company and a unique marketplace. We're developing not just the future of this company, but the future of manufacturing. And to be part of that is really quite amazing. We have a brilliant mix of the world's best and most experienced engineers that have got the freedom to explore technology and to push the limits. The entire point of it is trying crazy stuff, seeing if it works, and to shape the future of this industry. It's a mentality, no complex structures, just a desire to go and make things better. And it's exactly the reason why we've delivered just about every world first for this technology, and we'll continue to do that moving forward.
Hexagon introduces the future of manufacturing, revolutionary virtual manufacturing solutions aiming at shift to zero. Become part of this paradigm shift and drive your business towards production efficiency and sustainability. With our cutting-edge virtual manufacturing solutions, you can visualize and optimize your manufacturing processes in a virtual environment. Say goodbye to costly physical prototypes and hello to a streamlined workflow. On top of that, our system is designed to achieve shift to zero through innovative techniques and technologies. Reduce material waste, energy consumption, and environmental impact while maximizing resource utilization. Embrace the power of virtual manufacturing, where precision and automation come together. Our integrated virtual manufacturing tools empower you to create complex designs, simulate intricate assembly processes, and automate production lines for unparalleled efficiency. The future of manufacturing is here, and it's greener than ever before. Join us on this transformative journey towards lean and efficient virtual manufacturing. Together, we will create a more sustainable and prosperous world. Contact us today to unlock the potential of virtual manufacturing with the goal of shift to zero. Together, let's shape a better tomorrow.
qua, công nghệ in 3D kim loại đang mang đến một cuộc cách mạng trong việc tạo ra các cơ quan trong cơ thể con người. Và kỳ vọng trong vài năm tới, Việt Nam sẽ trở thành một trong những quốc gia có thể thay thế các bộ phận bị tổn thương của con người bằng công nghệ này.
Ghi nhận từ hội thảo công nghệ in 3D kim loại, những đột phá trong phát triển sản phẩm và sản xuất một số ngành công nghiệp vừa diễn ra tại thành phố Hồ Chí Minh. Tại hội thảo, các chuyên gia đã chia sẻ giải pháp ứng dụng in 3D kim loại vào lĩnh vực y học khi chế tạo được những phần xương nhân tạo từ vật liệu titan. Những phần xương này có tạo hình hoàn toàn khớp với cấu trúc của đoạn xương bị thiếu, được cấy ghép vô cùng chặt chẽ vào cơ thể người. Sản phẩm này được tạo ra qua quá trình bồi đắp vật liệu theo từng lớp chồng lên nhau, một xu hướng mới trong ngành in 3D hiện nay. Công nghệ này đã được chứng minh độ an toàn trong lâm sàng và đã được áp dụng tại các nước như Mỹ, Trung Quốc.
Cái công nghệ bồi đắp này đó là nó sẽ đắp dần từng điểm vật liệu, nhựa hay là kim loại, sẽ thiêu kết từng cái phần tử vật liệu ở dạng bột kết nối với nhau để tạo thành cái sản phẩm. Và hiện nay nó có những cái ứng dụng đặc biệt liên quan đến y học tái tạo. Có thể nói là đây là một cái triển vọng cho cái lĩnh vực y học tái tạo ở trong nước.
Lĩnh vực mà in 3D áp dụng vào ngành y tế là một trong những mảng mà được ứng dụng nhiều nhất ở trên thế giới. Và cái in 3D cho cái ghép y tế là nó rất là tối ưu, không chỉ là về mặt độ chính xác, kích thước cho từng người, cá nhân hóa cho từng người, nhưng mà nó còn giúp là kết nối với xương tốt hơn và nó tạo ra cái hiệu quả tốt hơn nhiều trong cái việc mà cấy ghép trong y tế.
Vinotech hiện là một trong những doanh nghiệp đầu tiên đầu tư công nghệ in 3D kim loại vào lĩnh vực y tế tại Việt Nam. Công nghệ này sẽ giúp chế tạo các thiết bị hỗ trợ quá trình phẫu thuật nhanh và chính xác, chế tạo các bộ phận cấy ghép trong cơ thể người.
Gần đây chúng tôi đã lắp đặt một cái hệ thống máy của hãng SM Solution cho một cái khách hàng rất là lớn ở Việt Nam, chuyên làm trong cái mảng cấy ghép y tế. Và trong vòng 1-2 năm tới đây thì chúng ta sẽ thấy là những cái sản phẩm in 3D kim loại cấy ghép trong y tế sẽ được làm ra tại Việt Nam, và tôi tin rằng đây là cái lĩnh vực mà Việt Nam sẽ phát triển rất là mạnh trong thời gian tới.
Để mà có thể áp dụng các cái sản phẩm này cho bệnh nhân thì phải trải qua một cái quá trình thử nghiệm lâm sàng và qua cái sự chứng thực của cái hội đồng y đức để người ta khẳng định rằng cái việc thay thế này là an toàn cho bệnh nhân. Và trên thế giới đó, nhiều nhất ở Mỹ hiện nay người ta sử dụng trong cái thay thế khớp gối.
Những năm qua, ứng dụng in 3D đã tạo nên nhiều phép màu khó tin cho lĩnh vực y khoa, chăm sóc sức khỏe con người. Không bao lâu nữa, các bác sĩ tại Việt Nam đã có thể tự tin sử dụng công nghệ này để tái tạo một số bộ phận cơ thể người, mang đến cuộc sống chất lượng hơn cho người dân.
It's kind of a unique company and a unique marketplace. We're developing not just the future of this company, but the future of manufacturing. And to be part of that is really quite amazing. We have a brilliant mix of the world's best and most experienced engineers that have got the freedom to explore technology and to push the limits. The entire point of it is trying crazy stuff, seeing if it works, and to shape the future of this industry. It's a mentality, no complex structures, just a desire to go and make things better. And it's exactly the reason why we've delivered just about every world first for this technology, and we'll continue to do that moving forward.
Ladies and gentlemen, the panel discussion will start in the next 5 minutes. Please find your seats and prepare for the next segments of our event. Thank you. Chỉ còn 5 phút nữa thì phần panel discussion của mình sẽ bắt đầu. Mong mọi người hãy trở về chỗ ngồi để mình có thể tiếp tục phần panel discussion của chương trình.
Hexagon introduces the future of manufacturing, revolutionary virtual manufacturing solutions, aiming at shift to zero. Become part of this paradigm shift and drive your business towards production efficiency and sustainability. With our cutting-edge virtual manufacturing solutions, you can visualize and optimize your manufacturing processes in a virtual environment. Say goodbye to costly physical prototypes and hello to a streamlined workflow. On top of that, our system is designed to achieve shift to zero through innovative techniques and technologies. Reduce material waste, energy consumption, and environmental impact while maximizing resource utilization. Embrace the power of virtual manufacturing, where precision and automation come together. Our integrated virtual manufacturing tools empower you to create complex designs, simulate intricate assembly processes, and automate production lines for unparalleled efficiency. The future of manufacturing is here, and it's greener than ever before. Join us on this transformative journey towards lean and efficient virtual manufacturing. Together, we will create a more sustainable and prosperous world. Contact us today to unlock the potential of virtual manufacturing with the goal of shift to zero. Together, let's shape a better tomorrow.
Hello everyone. METAMAN-2024 will continue in 1 minute. Can you please come back to your seats? So the panel discussion will start in a few minutes. Can you please come back to your seats so that we can continue our event? And now the panel discussion of the second section will begin. Please welcome Dr. Đậu Văn Huân on stage as the moderator of the panel. And as for the panelists, please welcome Mr. Hoàng Đức Bằng from AIE, Mr. Lê Văn Phú from Hexagon, Professor Dr. Trần Trung Dũng from Vin University, Mr. Simon C. from ELH Tech, and Mr. Vada from Hexagon.
What? It will be me alone.
Please, Mr. Simon C. and Mr. Lê Văn Phú. Please welcome Professor Dr. Trần Trung Dũng and Mr. Hoàng Đức Bằng from AIE. And here we also have Mr. Cameron from Hexagon joining online.
Hi everyone at the back, can you return to your seat so that we can start the panel discussion? Thank you. So in this panel discussion, we pretty much focus on the medical sector, and we also have our panelist, Mr. Simon C. from ELH Singapore. He will be discussing about aerospace application. But I think so far, all the three presentations that we had today, very interesting and very insightful, is about medical application. So let's start first with the medical application question. My first question would be to Professor Dr. Trần Trung Dũng for his amazing presentation on some of the actual application in healthcare in Vietnam, and very happy that in Vietnam there's such an organization that leading the way in applying 3D printing in healthcare, or more specifically with medical implant. So my question would be, when you apply 3D printing in healthcare sector, what are the biggest challenge that you face so far, and what do you think the future, the next couple of years, how the future would look like?
Okay, thank you for your question. And as I mentioned in my presentation, I think that's it in Vietnam. So many people want to apply 3D technology in medicine. So many doctors and so many engineers and company want to apply it, but we have so many barriers. The first one, we understand that's the high cost of the 3D printing, because in medicine, that's the personalization is a trend, is a hot trend. And we use the 3D printing technology in medicine must be the individualized. Therefore, the high cost is a very expensive. And the second one is that quite difficult to team up with. For example, the doctor and the engineer working together. The doctor give the question, and the doctor and engineer will have to discuss to figure out the solution. And the third barrier is just the hardware and software. Very expensive. Very expensive, so not easy to have the machine, have the software, and therefore so many barriers to prevent the applying 3D technology in Vietnam. And we try to find the solution for it. The first point, I think the most important point, is that we have to team up to be a group, doctor, engineer, and to work together. So far, in my center, we have a 3D group with the 4 engineers, a designer, and the machine operator, and work together with my doctor. And the second one, we have to get the investment for the hardware and the software, because it's very expensive. And if we think about the invest to get the benefits, we cannot to set up a 3D lab. So we are quite lucky, because when we introduce our idea, that's we get the support from the group. They're ready to invest for our 3D lab. With the first mission is research and education. But for sustainability, that's maybe all of you know that the research and education training is the first step to be sustainable. We have to get the investment. It means that we get the revenue enough to reinvest to our 3D lab, and that's the reason why we have to think that the 3D printing technology in medicine must be more popular. If it becomes popular, we can get reduce the cost for PSI, reduce cost for implant, and therefore we can commercialize. And to do that is not easy. We have to make a big network with so many doctors. We have to inspire the other to take part in the network of 3D printing technology in medicine, doctor, and when we have a big network and so many people want to use us, it means that we can come to the next phase. Is a mass personalization. That's a chance to be sustainable, because we can get the revenue from commercialization.
Thank you so much. I think that is really insightful, and it's really the answer from the person who really is doing it, and doing your best to push things moving forward faster. I will get back to you. I think a couple more questions, but before that, I would like to ask Mr. Bang and Mr. Fu and Camero. We know that applying 3D printing in medical field is very potential, and is growing very fast right now. But there's also a lot of obstacle. So you standing from the standpoint of a business that's supplying equipment or software or services to the end user, what do you think, if there is 3 things that you wish to have to make this process faster and more efficient, what do you think the 3 something like support, or the 3 reasons that could make it move faster? What do you think those are?
I think this technology is new in Vietnam, but already popular in the world. And see, there's many presentation for that. For the new technology, actually, you know that is a high investment cost, sure. But if you, like Dr. Dung said, that if you make it more popular, more people, so I think the price, the commercialize is lower cost and so more people. So we have to thinking about the big play. That is a big game is a very important thing. Yeah? But from the beginning, initial state, you have to find the right person. That's the right person is what condition need. First of all, he has money. Money is very important. With money, we can do. And the second, we need to find the person who is excited or inspired with the technology, like Dr. Dung. So you see that we have to do this so that we can understand, showing people that we can do, you can make it. After that, so Vietnam, I think is now we start also. Now is a very fast pace if in comparison with Asian countries. So I think it's now we get has good start, but we need now is to, like Dr. Dung said, we can make a more popularization. Also, we involve the government support, Ministry of Health, so that they can make a clear step, so that people can involve. So I think it's very important.
Yeah, thank you, Mr. Fu.
Mr. Cameron, you want to say something?
Okay, yeah. I think I would say top 3 things to accelerate the adoption of additive manufacturing in biomedical industry. In general, I would say that what we are doing right now is part of the initiative, like awareness that this technology exists, right? So it's a good avenue or channels to tell the world that this technology exists, and the presenters already explained that we have a lot of application elsewhere. And then number 2, I would think that I'm not sure in Vietnam, but in Malaysia and Singapore, there are some university already adopt additive manufacturing as part of the courses in the education. So it spread the awareness. It's giving the students opportunity to open their own company to develop the capability and services related to the 3D printing. So the university helped some of the students to establish a company, and students start actually offering the services to the clinical, collaborate with the doctors, and doing either prosthesis or implant and so on. And number 3 is the support from the government. For example, this company, in addition to the university supporting them, the government also offering the some sort of fund to establish by buying the equipments, yeah, and maybe it's like a 50-50 share between the government and the company, or maybe some sort of milestone that the government what we call it, put, or KPI that the government put, so that this company can continue to get the fund the following years and so on. So I think the education, the marketing activities, and support for the government is something that can accelerate the implementation. Yeah.
Thank you, Cameron. I think that's the very really makes sense. And personally, I think to make it like I really like Professor Dung's idea is that we have to gather people together to make it happen, and that's why actually part of the reason for this conference is also, I think we more like all the company here are 3D printing company, and we have doctor, we have people from university. So in my point, I think we should work together and collaborate together, so that to spread the news and also find a way so that we can make this technology in Vietnam as mature as fast as possible, and define the way that we will expand the market for medical application. And this is actually a rare chance that some an industry in Vietnam, we can do and build product ourselves, and do high-end product to the customer. So I really hope that we can work together to make it make it big, because AM is still very small compared to traditional manufacturing. So let's work together to make it bigger and bigger, and then I think everyone will have a part of it. So Simon, you have some thing to add regarding this question?
First of all, actually, it's like when I get to you all know so many medicals AM parts are quite impressive. We all know there are a lot of benefit through this process, to benefit the patient, to benefit the process, in order for them just recover easily. And this kind of technology already fully adopted in Europe and US, which is already in the serious production. Even in China, you showed me the slide. And this is just something, the beginning in the ways there will be more and more different industry can be adopted for the AM. Medical is one area where people already have a benefit. Dental, the other area will already mass in the market. And the rest, what about rest? Like engineering, like aerospace, like a defense, all kind of the process can be adopted for the AM. But back to the question, what can we do? I believe you mentioned about, hey, we need to build an ecosystem, get everybody to focus on the AM. But in my opinion, we should think the other way. It's not focus on the AM. It's focus on the different advanced manufacturing process. And the AM just one of the process, right? So this process can be the different way of fabricate from subtractive to additive. And we need to ask ourselves, what's the drive factors to push the thing move? Very simple. If I'm the just owner, the first thing I look at the cost. Right? I hear you oh, the equipment is expensive, the material is expensive, which is fact. But, when I look the back things 8 years ago, I start to involve for AM. Until the day, I look at the cost dramatically reduced, which is up to now, I can tell already reduced more than 40% from the time I invest for the machine. For cost me 1 million for one machine. But this is just beginning. There are more and more people start to interest to put in their investments to this technology. They will continue to drive the cost down. Of course, we need more engineer or more doctor like you all to develop the right process, which is to convert the waste from the traditional process to the additive mind. Or can be combination as a hybrid process in a way to develop the solutions. I believe that downstairs a lot of Vietnamese youngsters, you all have a full sort of potential to think about how to develop something different, which is, in my opinion, you go through the AM journey is not the option. Sorry to say that, because I'm from Singapore. Since I was study all the CNC machine, now all the things talk about 3D print. That's why I'm put away. It's not the option for you all. If you want to capture the wave, you need to start from today to learn something new, which is from the design perspective, from manufacturing perspective, from material perspective, and then get the final solution to equip yourself to know, oh, what's the benefit about this process can be benefit for your future, your career path. So wrap it up. I think this is not the, I will put it as it's just a beginning the journey. There are more things to do, there are more opportunity waiting for us, and there are more opportunity for everybody sitting inside the room to get the benefit from this process. That's my words. Thank you.
Thank you. Yeah, really insightful and really, talk from a person with a lot of experience and exposure in the AM industry, especially in Singapore.
May I have a question? Sir? I think for this new technology also we need to have support from the government. Also, you know that we make the noise so that people understand. So also it wants the government some policy like support for the new technologies, the taxes, and some. So I think it's I don't know if in Singapore if we have like a experience like this, if we have like a AM association for that. Also is how the Singapore government to support for this new technology. Do you have any share the experience?
I was so grateful like Singapore have a very good government, and they are very far sight to think about what's going to happen not for now, probably it's like 10 years, 20 years, 30 years down the road, right? So we do have the association called NAMI, National Additive Manufacturing Cluster. And this cluster, they just like a united different NAMI hub from a different university. And the different university or institution to focus on one industry. Example, we have National NTU focus on construction 3D. We have NUS will focus on medical like a 3D print. Whereas SUDD focus on design 3D print. They'll have a different hub to focus different area. And the other parts like a really government give a great support. And I will put the ways like you can imagine wherever the ADAS, the most expensive like 3D printer, you can see in your lab. But why do so? It's because like they need the people start to understand the process first, to understand the pros and cons. From this perspective, to think what's the better solution can be rolling to the market, or what kind of innovation paths can be applied to this technology. So that's why like we are in the process to doing so, and also government push a lot of funding for the industry have adoption. In fact, like last week, I just attend one of the E1 in Singapore, like related to semicon. And don't be surprised, Singapore semicon have a high adoption for AM parts, and they are benefit from that, which is the Singapore government will really give a great support as well. So I believe this part, I cannot speak on behalf of Vietnam government, all right? But what I can do is like, this is cannot be just like a work alone, must top down from, you know, like a government perspective to really get this institution or to benefit from the process and slowly to roll into the industry. Then I think that's the process. All right, thank you.
Thank you, Simon. So I also live in Singapore for quite a long time, and I have seen like how the Singapore government supporting the companies and the business. Probably most of the metal 3D printer in Singapore, I think supported by the government funding. Like top university like NUS, NTU, Nanyang Poly, and so on. I think they have money to buy those expensive equipment and support from the government. And one of the things I know is that like big company like Makino, they have a big factory there. And they have recently they start a new division called AM division, and half of the money investing in that big project, I think around 26 million or something, come from the government. So it's very big support, even for not to mention about semiconductor, like even you know much huge support from the government. So I hope that in Vietnam, the government would also be supporting in this kind of initiative. And in terms of association, I think we also have initiative from Professor Trần Trung Dũng to kind of establish the Association of 3D Printing for Medical. And I think that is the first step, and hopefully everyone interested in this can register and join as a member, so that we can unite and collaborate and grow it together. So in terms of medical application, one of the concern, or one of the challenge that most of the user have is in terms of the certification process. So from this perspective, normally it takes quite long, and not to, for medical application, normally to get something to get approval, it takes a long time. So I think regarding this point, I like Professor Dũng to discuss further and elaborate more on this point.
Yes, as I mentioned in my presentation, in Vietnam we have to follow the instruction from Ministry of Health, and maybe you know that for the metal printing implant to use for implant into the body. And so far, and no any company or any factory can do that, because for 3D printing it means that personalization. But for other products such as plate and screw, that is mass production. It means that they get the COCQ and certificates, so they can commercialize. But personalization, it means that we print each implant. And that's quite difficult, because we are the pioneer. Therefore, we get the consultation from the Ministry of Health, and they require us to do the 3 research, as I mentioned. The first is the biomechanic property test, and the second is the toxicity. And then when you get the result, you get the result from that to research. You come to the next phase, is a clinical trial with a small sample up to 10 patients, with volunteer patients, to evaluate about the safety of the surgery of the implant. That's only the safety. And therefore we have to do the surgery for, so far we are on our clinical trial, and we perform the surgery for 5 cases, as I introduced. And we have to follow up to the 1.5 year, 18 months, and then we report, and the minister will evaluate. And if they accepted our result, maybe they permit us to come to the next phase, to maybe we can produce and use routinely for the patient, but not for commercialize. Not for commercialize. It means that we have to get the support, financial support from maybe the government through the research, or from the philanthropy, from the, for example, the charity foundation from the group and some other foundation. It means that if we get the approval from Ministry of Health, we can come to the next step. But that's in you, we have the permission to use in patient, but not commercialize. It's still, we can consider that it's still in the research. And then we have to get the support, financial support from other. It means that we cannot sell to the patient. Yeah.
Thank you. So the complete procedure from mechanical test to toxicity test to clinical trial until approval, how long you think that process would take?
So far we finished just 2 tests for the mechanic property test. It takes maybe 2 months, and for toxicity we have to perform the implant to the animal. Then we get the sample and to check for the toxicity, anything, and it's up to 6 months. And now we pass on 2 tests and we come to the next clinical trial.
Clinical trials, or how long do you expect?
18 months. We have to follow the patient for 18 months, and we evaluate about the safety. It means that is there any abnormal locally and generally for the patient. That's only check for the safety.
Okay. Thank you.
I got one question regarding about these so-called clinical trials. So far, only titanium is like one of the material considered, right? Before the titanium, have you ever think about like a pig and like a cobachrome?
Yes. For pig PEEK, we get the approval from Ministry of Health in another research, and we use the PEEK material for maybe the from 3 years ago, and the research is a clinical trial only for titanium.
All right, thank you. But why is like questions like I know there are a lot of potentials to apply these two materials from like polymer perspective to the metal perspective in order to reduce the cost. The both material expensive, but versus to titanium and P still can have the option can be lower the cost. Because there will be lower cost, there are more people can be benefit. That's my point.
Yes, but you know that's when we replace for a part of the body, for example, for the lower limb, the PEK is not enough stable to have the patient to work. For example, the pelvic replacement, as I introduced, you can't use the PEK because it's not strong enough to support for the patient. That's the reason why we use almost a PEK for the upper limb, the humerus, for the radius and ulnar. But for lower limb, we have to use titanium.
You want to follow up? Yes, okay. Yeah. So in terms of simulation for medical application, I think from the clip of Hexagon, we see that though they developed from the complete case for hip implant. So may I check, like, for simulation, what kind of simulation do you do on that case, on the hip implant case? Cameron?
Yeah. Like we answered this morning, we do a printing simulation. But the interesting part about medical application of 3D printing is that, for example, the professor here explained about the hip implant and so on. We have one customers in Australia that they explained to us, even though we print perfectly symmetrical with, with the other hip that is not broken or something, human is actually, for example, they have their own way of walking. It's not like symmetrical walking. So the bones actually is not really symmetrical. So whenever you try to print according to the bone part that is not broken and try to make it symmetrical, when it is implanted inside the body, the patient will feel will hurt. They feel a little bit inconvenient or uncomfortable when they start using it. So one of the way to overcome this is to do a simulation of motion simulation. So we print that, we design it as a printed, and we try to see using our software, multi-body dynamic software, we try to simulate the working condition when it is implanted inside the human body or the patient body. So each walking scenario will be unique to the patient alone. So not only on the printing side, on the simulation, we also capable to help our customer to do the motion simulation for the patient uniquely. Yeah. Yes, Dr. Ho.
Thank you so much. So I'm surprised to see that the multi-body simulation is used for simulating the human walking. That is really eye-opening. So we have here, I think Simon have a lot of expertise in aerospace, making aerospace component for using AM. So based on your experience in Singapore, and do you have office in other country besides Singapore? And can you share some of the most of common case that you apply 3D printing for aerospace?
Okay, we start to serve the aerospace company since like 2010, and when we start like serve them as just like a machine lease, we supply those like jig and fixtures to them, and things like they need the special tooling to support their production. You all know like Singapore have a lot those MRO for the aerospace. So this is something give opportunity to understand the market, what they are doing in aerospace. We talk about aerospace, everything thinking like, hey, they need the certification like AS 9001 in order for you to produce the parts. But the actual fact is like the 9001 for AS is only applicable to flying parts. They still have a lot of non-flying parts, which is you can be served for. So since like the day we use the traditional method, CNC, sheet metal fabrication, until the day like we still rolling the 3D print process, I realize the adoption for the aerospace industry getting higher and higher. And we even have the cases to directly 3D print the cabin interiors. When right before this COVID started, like Singapore have a lot of flight want to convert it to this, cargo flight. So we are the one to involve to helping them to do transformation, so-called transfer from the passenger flight to the goods flights. So directly 3D printing become like a very effective solution. What we print just like a print to use. Of course, material selection is one of the criteria, but in the real market, you already have a fire redundant material certified by Boeing. What we do just took the same material, get the right design, print and use. This is the real case which is we've done in the past. Besides this one, like there are more things like ongoing as well. Like for aerospace, they still have a lot of the special process like thermal spray, plasma spray. And this process, they need different kind of like masking. And the masking, we used to be formed from sheet metal, but customer need to pay quite significant amount to make the mold and die to form this shape. But when we go for 3D print, in fact, we directly use the Autumn as the replacement of the sheet metal parts. We use the polymer to replace metal, and the result, fantastic. Even like they reduce the order, in fact, the one part can last even longer. This is just like two significant cases. Of course, we have many, many cases. We served aerospace, and there's more thing even today for the OEM they are using. I quote example, you all read the article like, GE to launch their new GE X engine. And this engine itself already more than 100 parts 3D printed, which is all metal. Just like, people doing it. People doing it. OEM doing it. You mentioned about Makino. Yes, I saw the Makino machine. Their GM also talked to me, asked like whether we can adopt their DED. We all know like a DMG, they are all 3D printer. We all know like a Solid, they are 3D printer. We all know like a Chrome, they have a 3D print. Why? The reasons like same back to the function I saying, 3D print is not option. all the OEM, they bet like 3D printing going to happen for the next 10 years, 20 years, 30 years from the all various industry. What we do today is like have to slowly to pick up to know how. This process, not easy, really not easy. But from the different industrial perspective, people start using. GE to acquire the company called Concept Laser. You share the Arcam also acquired by GE. There will be purpose behind. So this is just like starting. I will keep on mentioning like this is something like you need to transform in the way. Vietnam, I believe that they are picking market, which is have a lot of manufacturing, just like going to be set up in Vietnam. They are from Japan, they are from Korea, they are from different part of the world. What going to attract them have the more factory here? From speaking, that's what Singapore government doing. We need to give the solution to them. Give a better solution to benefit their current process, to help them to save the cost, to help them to adopt something they never adopt, or even they adopt in US and Europe. If we make it happen, I believe there are more manufacturing in Vietnam as well. So this is something I personally view like need to continue drive. But the drive always like from top down, from government, from institution, from the MMC, in end all the way to the SME. I'm start from SME, but the things like only SME can be really quick turnaround and understand the process better and faster. So I think like we should not stop revolute ourselves. Otherwise, like we'll be evaporate. Trust or don't want to move one day is not the option because the process is going to change. There are more and more parts designed for AM. So if you don't have the technology, if you don't know the technology, you will be just abandoned by the market. That's my view. All right, thank you.
Thank you, Simon. I think we are running out of time already. So probably can open for one last question from the audience. Anyone have any burning question that you like to ask?
Okay, so we do have one question from the live stream. Let me get it. So here he asked how to ensure that all patient custom implants have the required mechanical properties because we cannot test them like mass production method. Do you need me to repeat the question? Okay, again, so how to ensure all the patient custom implants have the required mechanical properties because we cannot test them like the mass production method.
Professor Dũng, you want to address?
Okay, thank you for your question. You know, that's because for the 3D printing implant, there's only one sample. Therefore, we follow the instruction for the testing center that we produce some sample and they will test the samples as the requirement. And after we pass the test, it means that we can produce a 3D printing implant. We don't have to test for each implant.
Yeah, thank you for your answer. Want to add?
Oh, I only little bit is like from an industrial perspective. We cannot be qualify all the single batch, which is like a non-practical. But what the practical ways like whatever the batch we produce, we always like produce the test coupon. We use the test coupon based on the orientation to test the strength of the material, to do a simulation about the part, whether be safe to use or not. I mean, so far, this is common practice from the different part, all the part of the standard, which is the result significant shows is validated and can be trusted to use. Yeah.
Yep. Camero, you want to add something for this question?
Yeah, I totally agree with Simon. I mean, that is a common practice in the industry as well. I mean, whatever you produce in terms of material, we create a coupon test, and then we do a test whether it is up to the standard or not. In terms of implant, we also adopt new workaround or solution that we do a scanning and we conform to the standard. Maybe ASTM team would know that there is a CT scan, and we scan whether there is a void inside there, whether there is a what we call a cavity, that the printing is not uniform. So that is where that we can see the quality of the printed part for the implant, whether it's conforming to the standard or not, and if not, whether it is still safe to be used, or we need to redo the printing and do another round of process again. Yeah. So the quality check is also part of the process, in addition to the testing that Simon explained just now.
Thank you, Cameron. So Anh Bang, you have anything to add, or if not, then I think we can conclude. Yep. Thank you so much, our panelists, for spending your time and answer all the questions. It really provide a lot of helpful information in insights. Once again, thank you so much. Yeah. And
Thank you, Dr. Huan and our beloved speakers, for your
Thank you,
meaningful knowledge
everyone.
about additive manufacturing in many fields. So before we leave the conference, can you please all join the stage to take the photo with us?
So I need to stand, is it?
Yeah, you can stand up.
It's okay.
Can you all please join the stage so that we can take a photo together?
Yeah.
Everyone, can we join the stage?